Cool, so I think we're live now, and my plan for this stream is to kind of carry on where I left off yesterday. Apologies about terminating that stream so briefly, had something to attend to, which I was kind of out of my control, but hey ho, I'm not expecting anything like that to happen tonight, so we should be better, I think. So, whilst I'm waiting for some people to join, I might as well explain what's going on. So currently, I've got one of my testers, Lexi, in Florida, or specifically Miami, at a W210 with EGS51 plugged into it, who's able to test. So I'm going to be writing code from this end over here. She's going to be pulling it from Git as I'm making the changes live on stream, and she'll be testing out my changes. So for the first change that I want to do, we found out last night after stream and everything that the start enabling on EGS51 is done via a physical relay and not via CAN bus like it is on EGS52 and 53. So if I get to my desk view, now you can see on my TCU here, I've got a little LED here. Now what should happen is in park and in neutral, that LED should be lit to denote, to basically say that it's closed that relay so that the car can start, and that's what I want to get working here first so she can actually start the car with my TC plugged in. In reverse and any other position, it should be the LED should turn off to basically tell the car which it can't start. So I think we should start that first. So go back to my desktop scene. Okay. And also on this side of my screen here, I've got a CAN dump from her car, which she's gracefully done for me already, which is really, really nice. So I've been using that to kind of compare some CAN data and work out roughly what's in what CAN frame, which has been going on really well. Also, you guys might notice there's no fan on this stream. It's a bit cooler today, so I'm not having the fan on, so you guys can hear me a little better this time. So, without further ado, I say we get started. So, to start off with, I think there is in the datasheet PCA 9535. So basically, if we go to GitHub about the TCU schematics, to explain what I want to do first. So I need to go to schematics 1.2 PDF. So, on the TCU, this is the I/O expander which deals with the old school shifting stuff here. Now you can see I/O 0 is hooked up to all inputs, so brake sense, programming button sense, kickdown sense, A, B, C, D for TRSS module, and I/O 1 I've configured as, I want to configure as outputs so that it can close or open the reverse park solenoid, or it can close or open the start enable solenoid. So I need to work out how to set I/O1 to output, because by default I believe they're both inputs, but we shall see. So what I'm going to do is I'm going to go to EGS51 can.h, go here and say boolean start enable equals false, and boolean rp lock engage is false as well. So we set these both to false when the TCU starts up. Okay, and I'm also going to zoom in so you guys can see the screen a bit more. And with that, what I'm going to do is I'm going to go to EGS51.cpp and set safe start, set safe start, and just to basically say that this, what variable did they call it? It's start enable is equal to can start, and then in the I2C query loop we will just basically set this state here. That should be a very simple task to do. So I go now down here to I'm querying the I2C module, and I now need to work out how to do this, what data I need to send. I'm currently just having a look at the datasheet for the PCA module on my second screen and working out what I need to send to it. Okay, so from what I think we can do is we can change request bytes. Okay, so let me just quickly make sure that I'm on the right branch before I make changes. I think I should be on EGS52, EGS51. Yes, I am. Cool. So we can work this. And I'm also having a look at some example code as well from an Arduino library, which also deals with this same PCA I/O expander. Admittedly, it's for the Arduino library and not the ESP-IDF, but I can pretty much translate that code. So. Okay, so this seems pretty simple to do, I think. I just need to set those two pins to outputs first. So we can do that in our setup function, I think, where we can actually check here about set RP and start pins on IO expander to be outputs. So these will be port 1. So it'd be I2C underscore write master write to device. I2C port is I2C non-zero. Device address is IO address. UINT write buffer. Oh, I need to actually set these. UINT 8. Write buffer is 2 is equal to 0, 0 by default. Oh, okay, this is interesting. It says that outputs should be low and inputs should be high. So then that means we want FFFF for everything for now. Because you want these all to be inputs, unless I specify that they want to be outputs. Okay, no wait, I see what's going on here. I see what it's doing. Okay, so we need to do 0x07, so this is set IO OX06 port 1 is plus port 1, set everything to input, and then we want the last 2 bits which are on the PCA module, which pins. I'll go to history, open up that schematic file. So it'd be IO0 and IO1. So in that case, then the second byte should be 0B00123456. Because I want the IO0, IO1 output, IO2 to IO7 input. Ooh, there we go. So now I want to write that to the master, so we say write size is write buffer 2, and we'll wait 50 milliseconds to do that. Res is equal to that, and if res does not equal ESP OK, then we say failed to set pin mode. Okay, let me upload that. Let's see how that goes. Okay, it seems to be okay. And actually, then now down here is I need to set the pin mode for those two pins. So which pin invert? I want digital right. Okay, so this is pretty simple now. So now I have to say request 0 is equal to the port number, which is 0x01. Rec 1 is equal to all that. Okay, so I'm going to say all 0 for now because I'm going to edit that. No. There you go. Bit. Start enable bit, and then what pin will start enable? It's bit 1. And then yeah, so first bit, otherwise it will be 0, and then we have to write that to the device as well. E is equal to write to device I2C master write to device, and we're not going to listen for any request message. Could not set pin mode. Could not. I will eventually expand that to include the other bit as well, but I think for now that's okay. Upload. Oh, I forgot the close bracket. So that's returning ESP fail. So it's not liking that. Okay, so let's instead return master write read and just see what that does. I mean, if it is okay, then we'll just ESP log I shifter, and I'll just do the return byte O2X, which would be this. No, we want U28 resp temp to. I want to actually throw you into this, not the pre-buffer. There we go. Resp temp 0. Resp temp 1. Upload that. Serial monitor. There we go. So we got C06. I don't know what that means, but what I'm gonna do is I'm also going to just say what the value of start enable is. ESP log I SE enable state %D can start, so we can see what the value should be. Can everyone hear me, by the way? Just thought I'd quickly check now. Can everyone hear me? Should have checked that earlier though. Okay, so enable state is 0. So let me go ahead and move my, you can see it's spamming 0 there. So let me go ahead and switch over to the other camera, and I'll see if I can enable the. So basically, what I have to do is I have to manually enable the Repark lock contact on the conductor plate, because that's what it's monitoring. Okay, I'm not seeing anything. So we now have to work out why that is. So enable state is working. That's working fine. You know what? Let's set this to OXFF and just see what happens. So port 1, everything OXFF. Just turn everything on. Again, C06C. Let me go and move the Park Solenoid again. Makes no difference. So we have to work out why that is now. Okay, so it's made no difference. It's still spamming C06C, which I'm not entirely sure what that's meant to mean. Cool, you guys can hear me. Sorry, I just literally now just seen the chat. Okay, cool. That's good to know. Okay, so what I'm going to do is I'm going to actually set one, so I think I'm misreading this. You went temp, and we'll just say that's 0. Cool, Lexi will join in like 5 minutes or so that's good. She can come help now. I2C read, I2C master read byte. No, I2C master read from device. That's the one I want. I want I2C none 0 is IO address. Read buffer is untemp. Size is 1. 650. I just want to see what is equal to 1. Register 1. Or no, IO port 1. Yeah, register 1. Read me that state. So tell me what that state is. C. So if I go to C in binary, what is 0x6C? It is 1101100. Well, this makes no sense as to what I meant to interpret that to be. Maybe it's because I'm not setting the I/O correctly up here. Okay, let's set all the let's set them all to outputs on that pin and see what happens. FF6C. But FF is... Ah, it is the right byte. So it is returning the correct data now. But it's putting that in this one. Okay, let me move the reverse park solenoid quickly off screen. Just want to see what output it makes. No, it's made no difference. So now I'm gonna have to just work this out. Ilkozek, EGS51 with a plus minus gear selector. Is that a valid car configuration? I thought EGS51 was only ever provided in cars with 4321 on the shifter. I'm confused about that. If you could elaborate on that, would be very nice. It's a crossover model. Can someone link it? Like, what do you mean by crossover? Oh, 00 to 01-ish. Oh, okay, so if you have EGS51 with a plus minus gear selector, you actually don't, you kind of have a crossover EGS51, so it's EGS51's physical hardware, but the software running on it is the same software found in EGS52 in terms of the CAN matrix. So basically, you just need to drop in an EGS52 module and it will work fine. So yes, I would say my TCU would support that, because I know we have one of the testers in my group with a 210 with EGS52 in it, which is again late 1999 crossover. So yes, I think it should work. Still having FF6C. I'm not too sure what that 6C means, and it's annoying me. Still not doing anything. Oh yeah, I hate this. I hate doing I2C as a communication protocol. It's awful. I mean, okay, it's not too bad, but just, I hate doing it. Oh, 0x02 plus port. Okay, so I need to actually write the port. In that case, it would be 0x03. I think my request bit was incorrect. FFFF. Well, thanks. This is really useful. Okay, let me play with the RP solenoid again. No difference. Actually, just for sanity, I'm gonna check what I'm actually writing to the ESP. So that's ESP writing that, and that's IO writing that. So I'm going to just write down the bits that I'm setting. So I'm writing 0300, and that should change when I press the reverse park solenoid in. Cool, it does. So I'm writing data differently, so I know that my sanity check here is working. Actually, I'm going to make it even more abstract. I'm going to say OXFF if start enable is set to yes, otherwise 0. Did I delete another line? I did. Lol. From, oh wait, I'm reading the comments now. From, hey Lexi, nice to see you here. Okay, you say, Airco says from 08-2000 you probably have Bosch ME 2.8 in different CAN. Yes, I would agree with that. Actually, AB104, there is also crossover with EGS52 and EGS53, so there are two 11s out there with EGS53 in them, but they run the software on EGS52, and same for some 906 sprinters. Let me just make sure I'm setting the modes correctly up here. So this should work. Yeah, so command byte, which is the first byte I send, should be 0x07 for configuration of port 1. So 0x00, 0x07 there. Then input port register, output port registers, port register, configuration register. Here we go. So they're all by default. Which is set, which is one corresponding pin is enabled an input with high impedance output driver. If this bit is clear to 0, corresponding pin is enabled as an output. So that should work as intended, where I'm saying 0x00, so set everything on port 1's register to 0, meaning they all go to outputs. And then set it to command bit 7, which is 6 plus port 1. So 6 is configuration port 0 and 7 is configuration port 1. So I think that bit's correct, but I just don't know why we're not doing anything down here now. Let me just make sure my request is correct then. So OX03 should be output port 1, correct, and request 1. Output port registers. It's registers now, port only. Let's replace logic levels, pin to find output 6 and 7. So that should set them all to outputs and say output. But what do you respond with? What you respond with is weird. F. What's that meant to mean to me? Okay, one sec. I'm actually going to turn the fan on because it is actually pretty warm in here now. Okay, hopefully that's not too loud. I apologize if it is, but it's a lot more bearable now for me. Okay, let me just quickly check how I'm reading. So by default I go request 00 whenever I'm reading the port, which I know works fine. So 00 is input port 0. Zero because I don't need to write anything to it. Yeah, so this should work. Okay, time we do something else. Let me actually hook an oscilloscope up to that pin, because maybe it's not turning on the relay or something like that. So let me actually very quickly go to my desk scene, and I'm going to hook a oscilloscope probe up to the I/O thingy-mabobby. Give me 1 sec to do that. See, so what I find interesting now is the fact that those are high, meaning that it should turn on the solenoid. Okay. Let me just quickly do that by pressing the RP solenoid on camera, and you should see the lines on the oscilloscope drop. Or they don't. So we know we have to fix something there. Okay, so let me try that now. Yeah, it has no effect. So again, looking at PCA datasheet, so just to double check I am saying the right command, I then want to say down here, hey, 0x03 should be output port 1, which is what I'm looking for, and the second byte to write to it would be AB104, your comment about NAG2 is capable of controlling gearboxes back to at least 0796. So that's partly true. If you have a board which is fully assembled, because EGS52 seems to come in two flavors, one with the left side of the board being fully componentized, and one whereby that part of the board is blank. If you get the part of the board, if you get the one for the part of the board which is blank, I don't know the part numbers, then yeah, you can't. Yeah. So this is really weird that I don't understand why this is not working now. This is mildly infuriating. How many people are currently watching the stream? I haven't actually checked. Oh, we have 12 people watching right now. Cool, cool, cool. Cool. That's better than what I thought we did from this time yesterday. I'm actually going to set this array to 0, 0, just so I know that it's not accidentally just not writing into it. No, that is correct. That is what actually the I2C register is sending. Huh. So read a little bit more down here about how to write to it. Write to configuration registers. Slave address, command byte, data to register, data to register. Why is it writing 2 bytes? Alfredo says, also, do you have any plans to open sourcing the code? It's already open source. You can go to my GitHub. I'll actually put a link to it in chat now. Let's do that now. GitHub. And I'll pin that here. Pin message. There we go. So yeah, for people who are like, is it open source or not? Yes, it is open source. And yes, you can also have a look. Also, let me quickly close Steam because I don't actually need that open now. There we go. Closed. You see how someone else has done it. Oh, Alfredo, the repo I've given you is the main one. If you go to the README, there's a link to the actual firmware, which is what I'm currently editing. So there's 2 repositories. That way it kind of keeps things a little sane. Because I don't want to make like so many changes in one repository for like different apps and different parts of the TCU. So what does read modify? Okay, I'm just going to do PCA 9535 Arduino. How has someone done it here? So right reg. Okay, let me just quickly see how they're doing it here. Kate, no, I need to open up Kate, which is on my second monitor here. Okay, so with that in mind, if I go to pin mode, what was he doing there? So is it writing 2 ports? See, I don't understand what this means here. Why is there a third byte that I'm not writing, but yet somehow it works when reading from registers? Start condition, acknowledgement from slave, data to port 0, data to port 1. And my command byte, data to port 0, data to port 1. What's my command byte? Command bytes. Do we have any examples of writing data to this thing? Okay, I'm going to find some more libraries online of people who've done this, because this is really, really weird. It's also weird that it's being held high right now. Because if it's being held high... One sec, let me quickly go to my desk and try grounding out one of the pins and seeing if the light turns on. Oh, there we go. So I'm going to ground out the RP solenoid line and just quickly see if that makes the light come on. Okay, I found the problem. The problem is that my wiring is not correct. So start enable needs to go to plus 12 volts. Let's not short it out like that. Ah, so okay, so this goes to positive, and then negative goes to start enable. So it appears now my oscilloscope is showing that line of being 0 since I accidentally shorted it out whilst testing something. So either I've broken the MOSFET or I've broken the NXP chip. So let me just do a little bit more diagnosing off screen, but you might see the site. Actually, I'll move my camera around to there so you guys can see what I'm doing on the TCU. Let's do that. So let me move over to my other desk, because this is basically a second desk that I've got. So I've got two desks at like 90 degrees apart from each other. Oh, don't move the wiring like that. Okay, so we're now on this desk. So 12 volts. We might have actually just killed this MOSFET. That's pretty funny. Because this is outputting 0. Or we might have killed the PCA chip. Ooh, that's more worrying, if I've killed the PCA chip. Don't worry, I have spares, because I'm intended to kind of... well, I expected myself to kill these things. So let me just unplug the whole TC and plug it back in and see what happens. Okay, so now probe it. Yeah, we've definitely killed something, because it's now just showing 0. Where's my multimeter? Let's see if it's the MOSFET I just killed, in which case it's an easier fix. So we have 95 ohms between gate and ground, and we have open circuit on the other one. So it looks like it's just the MOSFET which has died, in which case I'll just get my heat gun and we can replace that pretty easily. So let me do that now. Unplug all of you, and let's just yeah, let's solder a new MOSFET on. Now, luckily, I've got this nice little box here of spare MOSFETs that I've been testing, because I've been testing these new Infineon MOSFETs to replace the NXP Buck ones that I've been using all this time. So we can just rip one out of my little salvage box, and we can put that on the board instead. So I'm just going to heat that MOSFET up, and we're just going to pull him off the board. Sorry Lexi, this is taking time. We might have just... I mean, I didn't want this to happen in your car, so we have to sacrifice something here. Put new MOSFET on. I'm not really too worried if this doesn't look nice or not, because it's just for testing, and likely thing is that I will kill another one whilst testing. So there we go, that's done. Plug it all back in and fire it up. Oh, my USB cable's gone down there. There we go. Hey, there we go. We got 3.3 volts across gate. So, I know we now haven't killed it. Cool, so we'll probe that. So, we said... And we just killed another MOSFET. I'm stupid sometimes. Okay, but let me just quickly see which side is ground and which one isn't on here. So you got positive voltage coming in to this one. So that doesn't do anything. How about the other way? Yeah, so that works now. So what we actually want is we want this one to come to start enabled here, like that. That's what we want. But of course, me doing my wiring wrong messed up another MOSFET, so time to take MOSFET number 3 out and solder that on. Yeah, see, the solenoid, the TCU is off currently, and it's still showing a nice bright light, so it's definitely shorted the MOSFET. Stupid thing. So we're just going to take this one off and put another one on. And then we should be done with all this jiggery pokery. So let's take another MOSFET out of my bag of tricks. Another non-dead one. Oh, there we go. Okay, that's good enough. As I said, for my purposes, it does not need to look pretty, it just needs to function as intended. So, this needs to go to power. Like that. Then we will plug TCU power in. Plug. Hey, see, now it works. Cool. That's that mystery out the way as to why it wasn't working. I was just being stupid and blowing a MOSFET. Feeding here to make sure the resistor that I've got in there for current limiting isn't getting too hot, and no, it seems to be absolutely okay. Oh, move my microphone back to my main desk. There we go. Okay, I'll boost the audio level, Lexi. I've just seen your message. Is that any better? Boost it just a tiny bit so it's not overwhelming. So you can now see that I've got the little blinky light on the TCU there in the corner. So go back to my desktop, and now we have to make this work so that it can change. Okay, Lexi, cool, thanks for the fact that it worked. So anyway, quickly flipping to my desk view, the blue line is the trace from the solenoid which controls that locking out contact. So it should go to low, which is what I'm hoping it does. It goes to low when the reverse part solenoid is engaged, i.e. saying you can't start the car, and it will go back to high when you can start the car. That's what I'm hoping. Make sure I've configured the port correctly. Right, buffer 2 is equal to bit 0 or bit 1. Oh no, I'm getting confused. There is two AB104. Sorry, there is two not solenoids, but two MOSFETs which the TCU controls. One is for the RP lockout contact, and the second one is for the starter. So I'm controlling the starter one right now. But reverse park solenoid I should also figure out how to do soon, so Lexi doesn't accidentally shift the car into park when moving. Because that's what I now have to take command of that and stop you from doing that. $412, you were not happy. Oh, sorry. Yeah, I don't want to put your car into reverse at like 60 miles an hour, so let's not do that. Nah, the thing is, Lexi, you just don't want the parking pool. Just get rid of it. You don't need that on your transmission. Just literally just yeet it off the car. Okay, I'm uncommenting some code right now to see if things will work. So why, with everything turned off, am I getting 3.3 volts on that NXP on the output? That doesn't make sense, because I'm looking at my oscilloscope right now. I've uncommented all the code I've already done, and I've still got 3.3 volts as shown by the high blue line on the oscilloscope. Let me just repower the TCU. I think the NXP chip has to restart itself. So the real question is, where's that 3.3 volts coming from? Because in the datasheet it says when the thing turns on, they're both configured as inputs, aren't they? So there shouldn't be any voltage on it. So bearing in mind we're on port 1. Port 1 is the pins in question that I want to modify right now. Input port only, it reflects the incoming logic. I don't understand why I'm getting that 3.3 volts on. One sec, let me just quickly power up a older TCU that's on my desk. Same EGS50 Ultimate-NAG52 board, but it's one that I haven't modified any code on for a while. And I want to see if that still gives me 3.3 volts on the solenoid pin. Not solenoid, the MOSFET. No. See, so when I ground this one out, I get 0 volts. So it's definitely something that I've written, code-wise, has made it jump to 3.3 volts. Okay, well, I found the issue. So basically, it seems that the TRS module actually can supply power to that NXP chip, keeping it on so the configuration on it never clears. So, with that out the way, now that we've realised that that's the problem, let me now uncomment all of this code and see what happens. So it definitely changed configuration there. Because you saw that it jump as soon as I uploaded it. So let me just quickly keep this on screen and change it now to an input. Upload that. Okay, see, so now it jumps down to low. So we're definitely doing something correct. But I'm just not sure what we're doing, because it's doing it, but like doing it wrong. This is kind of funny. So let me go back to my desktop scene so you can see what I'm now doing. So we say configuration of port. Actually, let me not output anything here. Yes, we're not outputting anything there. Okay. Right, buffer 1 is equal to... where's configuration? Configuration registers. Upload this. So these should now be configured as outputs, but then nothing should be written to them. No, it goes up, but I'm not writing anything to that register, so I'm so confused as to what it's doing that. See, look, it's gone up to up now. Okay, so let's see what happens now. Okay, so that's correct. So let's knot this again so we say that they're outputs. And then let's just say we want to write in a sequence OXOF. Which is to say low. Then that should keep it low, I think. Nope, it doesn't. Okay, what about OXOO? Doesn't change anything. Oh, that's very interesting. So I'm going to blank this bit of code out again and just quickly have a look. Brilliant. Okay, so even though this might not work as intended, because for some reason whenever the pin is configured as output, it immediately runs to high. If I keep reconfiguring the port registers, then that's fine. it will do the same thing. However, I should probably put that as 2 notes. So Lexi, we're going to just quickly test this, and then we will see if you can try this and see if you can start the car. So set these to all inputs by default. Oh. And then if start enable, then write buffer 1 equals write buffer 1 or not bit 0. Try this again. Oh, I'm an idiot. I'm literally writing this. I'm literally overriding myself there. Okay, upload that. We'll go to this view. Nope, not doing anything. So I'm gonna just say start enabled is equal write buffer 1. Okay, so it went to 0. So let's see what happens if I press this. It works! It works! It works! Look, go to my desk view. So if I push on the valve body, look what happens to the light on the LED. So that works like a charm. Let me just very quickly probe the RP solenoid to make sure that that isn't being inadvertently activated. Cool, it's not. Right, Lexi. Time for you to do some testing. Just a quick question, Lexi. Did we, last night when you were testing, did you say it was 12 volts when we can start, or it was grounded when we can start? I'm waiting for Lexi's response in chat. Grounded, I believe. Let me double check. Okay, I will let you double check. In the meantime, let me push... No, let me write some new... Let me just finish off some CAN changes that I need to make for you to actually... for the TC to send out the current gear it's in. So this is the TRSS code that I wrote, and then where's set actual gear? Here we go. So actual gear. So this GS2. Oh god. Switch actual. Just let me write these case statements up. Shorter pins. Okay, so yeah, so I'm doing it correctly then. When I see the light on, then that means it can start. Okay, cool news, Lexi. I'll just quickly push these. I'll just quickly change these set actual gear and set target gear statements, and then we can pretty much push. That way the TC can transmit to the rest of the car what gear it's actually in. Switch target. Now I need to quickly try something. I'm gonna try this. I'm gonna go to readme.candata.txt for EGS52 and rename these CAN frame names to GS51218 and MS51. Move these to trash because I don't need them for now. MS51, GS51. Right, so cd lib EGS cd lib. I cannot type for shit right now. Python convert.py. Oh, cat gen headers. Let me see how I'm doing it. Yep. Python convert.py EGS51 ECUs candata.txt EGS51 ECUs src and EGS51 mode. Cool. So that's generated these two headers. So let's quickly go to EGS51 and change these to include GS51.h. There we go, that fixes the include problems that I had. Cool. So this GS218.set GZZ, I think, is sets target. No, it's set JIC. And then GS218H JIC is drive 1. Second, third, fourth, fifth, park, neutral, reverse, 1, and this is SNV. SNV, GR2, GR, GN, Park, D5, 4, 3, 2. Cool, so now copy this switch statement and paste it into set target gear. And instead of set jig, we'll be doing set GZZ. Cool. So switch target. So now in theory, let me just quickly run let me upload this firmware and run can dump in another window. Can dump can 0. Oh, sudo IP link set can 0. Type can bit rate 500 kilobits per second. IP link set can 0 up. Can dump can 0. Cool, so it's 8.8. If I move TRSS over, 7.8, 2.8. Okay. I've got good news, Lexi. We can try this. So let me quickly go to Git here. God, I'm going to have to add a lot of stuff here. Main.cpp, so we can add that in. We can add EGS51 CPP, EGS51, 51.h, gearbox config. Yep, we can add that. EGS51 livestream changes. Git push. Okay, Lexi, I think they are... Oh, wait, shoot, I need to add these. These, I forgot to add the correct CAN data stuff. Whoops. Missing headers. Git push. Cool. So now what we have to do is we have to give Lexi's car inputs, because currently if you see all of these like getters which are further up here, like get engine RPM, get oil temp, get coolant temp, they're all 0 right now because the car has no clue what's going on and I haven't programmed in the correct CAN data yet. So luckily I did some comparisons earlier today and I found that the ECU for my engine is, well, in W203 is near enough the same, so that we can add stuff like pedal input. I pretty much have guaranteed that that's in the right location, the CAN frames, already by using a Python script I wrote. So I will find, for instance, PW. I know this CAN frame is correct. I know MS210 is correct. Except it's missing the... So we'll go here, so ECU MS. There we go, copy you in. Except I know from this one that 210 is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's correct. And we also said which other CAN frame was the same. We said the one for pedal position, get PW. We also said this one is the same as well, based on what we tested, which is... Oh no, which is 210. Engine speed. Yeah, 308 is also the same. So we'll copy 308 in. Okay, and then we'll run the Python script again. Go. Cool, so now we have these very big type def struts. So we can now check to import frames, which I'm going to do here, EGS51 CAN. Oh, I need to import the correct header file. Hash include ms51.h2, we'll include that. And we'll say ECU ms51. Oh yeah, that's what I need to do. I need to import the ms51 ECU ms51. Equals ECU ms51. We'll just initialize those there. Go to CAN bus. If this ECU ms51 dot import frame uint64 is temp, CAN ID is rx dot identifier. Now then do nothing. Ooh, crap, there's one important change I need to make, because I remember now, in all of these headers here in the import frames function, I had to fix a bug a while back. This is it. Let me copy that and change my Python script to add that in, convert.py. Where's import frames? This is it. So now minus last frame times is greater to max. Yeah, so this also needs to be it. So that should fix that bug. Make sure we generate those again. Cool. Done. That was easy. So now with that, we can go up here and we can do the getter for pedal position and engine RPM. Get pedal position. If this ms51 dot get ms210 I forgot how importing works on all of these. Yeah, so this should be pretty much a carbon copy of the two statements. There we go. So that should be pedal position get. Static torque, we ignore that. Coolant temp, oil temp, engine RPM, this is also something we need. MS608, MS308, sorry. 308. 308. Get and mot, I think is the correct signal. Cool. So now we have to test this firmware, so let's upload that to the TCU, and in the meantime I'm going to create a quick player to replay these CAN frames. Cool. So actually what we can do is we can go to e300.txt, find 608 on here, this one here, and we can just do a can send this. Okay, so with that now sending this can frame continuously on the bus, what we're going to do is we're going to open up the config app and see what the engine RPM is. Code Ultimate-NAG52 CD config app cargo run. Oh yeah, I'm an idiot. I forgot to add in the ability for you to actually query that data. Sorry if the config app is really small. Currently I don't have a way of scaling it. So what we'll do is we're going to open up config app, here we go. Terminal, new terminal. Git diff, there should be no difference. Git checkout EGS51, or git branch EGS51. Cool. Switch branch to EGS51. So now what I want to do is I want to create some extra data in one of our RLIs, which stands for basically record local identifiers, which lets me query data from the ECU. So to do that, I go to RLI.rs and we're going to find where I have the data can dump. There you go, data can dump is here, so I need to find that same RLI in diagnostics folder. Diag kwp, it's in diagdata.h, I think. Yep. So let's also add in a couple more. Where is it? Yeah, here you go. Pedal position, min torque, max torque, static torque, left wheel, right wheel, shift button, shift button. So I'm going to say uint16 engine RPM. We'll add that at the end of that strut. And we'll do the same thing here. Pub engine RPM U16. Why didn't you just download the code as a zip? Or like, wait, which extension are you installing, Lexi? You shouldn't need to install an extension, I think. Oh, maybe I'm wrong. I'm using Linux. So I'm just not going to comment on that. Lol. And we're going to say, we're going to actually put another one here saying engine RPM. Engine RPM. And then if self.engine RPM is equal to U16 max, signal not available, otherwise engine RPM. Cool, so that should be that side done, where I should be able to see the engine RPM over CAN. I just need to upload it onto the TCU, which involves changing diagdata.cpp to include it. Here you go. Then you just want to put return.engine_RPM equals CAN layer get engine RPM now 250 millisecond valid time. Upload that. Upload diagnostics RX data. Huh, engine RPM is still signal not available. That's interesting. Wait, how often am I sending this? Because it could be that it's timing out. Don't need this terminal. I've got way too many terminals open, I think, is my problem right now. Yeah, I do have way too many terminals open. Okay, this one. Don't need this one. Oh my god, I've got like 50 terminals open. Jeez, let me just quickly. Yeah, so this is the one still running. Ah, no buffer space available. That's interesting. So it's crashed CAN dump. Oh, because we're sending the wrong CAN frame. I'm an idiot. I've just realised that. So we can safely reopen this and go to diagnostics CAN RX data. And we'll start polling. I'm going to find... So remember, we said it's MS308, so I want to copy the CAN frame 308, not 608. So we want to copy... 308 is this one. And we want to go to my command where I am spamming that to CAN bus and edit this bit so that it sends 308. Cool, and now if I go to my config app, hey, look at that! There we go, 3,850 RPM. So engine RPM is now being broadcast correctly. So I'm also going to send another CAN frame as well. Can send CAN 0. And I want 210 this time to see if we can also get pedal position up. So let's send 210, which is just before that. Copy you. So it should send 2 CAN frames out that I want from the engine. Cool, go back to the config app. Hey, check that out, there we go. We got 100% pedal position and 3,850 RPM. So this seems to be working a charm. Now, I also mentioned that I think I found some more CAN data which is the same between our two cards. This will need coding changes, so I will have to close down the app for now. But basically we think that the BS ECU, which is also known as your ABS module, is the same between 210 and 2 was in the CAN IDs. Yeah, I will do, Lexi. Let me just see if I can get the rear wheel RPM sorted, and then you might be able to actually shift gears. And just let me know how it goes. But it's going to be very, very gentle when changing gears, because, like, as in very light throttle, because the car doesn't, well, TCU doesn't know how much torque the engine's making, so I think it assumes 0 Newton meters. So all the shift pressures will be selected as if it's shifting under 0 Newton meters. That's your word of warning. So CAN data, so we said that also we think that BS ECU, BS underscore. So we know 200 and 208 exist on, so we're going to say 208 and 208. So I know these two frames exist on the other CAN bus, but we're not too sure about any other ones, so we're going to just copy these ones in. Generate that, please. Thank you. So now we have another ECU called ESP51, which I can import. Include ESP51.h. ECU ESP51. ESP51 equals ECU ESP51. This ESP51.import frame, so we'll check basically for MS, then ESP. Okay, so now it should be simple copy paste, I think, for the rear wheel RPM. Rear, get the right rear wheel. Here you go. So I think these should be pretty much the same. Get rear. I just have to do some corrections here. ESP51. Okay, so that should be all the changes I need to do theoretically. So let's upload this. You should be able to see the rear wheel RPM now, meaning that you can now AB104, are you one of my testers? I'm just reading chat. Ah, you are. Okay. So I'm going to also copy 202. Ah, that's you, Daniel. Okay. Sorry, just checking. Right. So I'm going to copy 200 and 208, which I suspect are from the ESP ECU with rear wheel RPM data, and we'll see if it makes sense what's going on in his car, in Lexi's car, from the CAN log he sent me. So cargo run that. Launch, diagnostics, control loop, CAN RX data, so we don't see anything yet. Actually, let me set this to dark mode just so you guys don't bleed your eyes. Let me go to this, and I have to send. Wait, which CAN frame is that I just copied? That's 200. And also can send CAN 0208 hashtag, find 208 frame, then you go the next one down. So that's probably from ESP. Moment of truth. Hey, look at that. We got correct rear wheel RPM. Okay, Lexi, I'm going to push your changes to Git, and show me, if you can show me on the video, what the config app is also showing if you go to diagnostics. You need to quickly click the loop query data and then do CAN RX data. So let's push these changes now. So we need add, 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 add. Okay. Okay, so changes on the firmware are now pushed, so if you pull that, try building for your TCU. Meanwhile, I'll push the config app changes. Okay, so changes are now on EGS51 branch for the config app Lexi. You can try those. Now, whilst we're waiting for Lexi to test my changes out and tell me if things are working or not, does anyone here want to ask me any questions or something? Like, feel free to just ping questions into chat. I'm more than happy to answer them whilst we wait. Also, Lexi, I should quickly mention, as manual mode doesn't work right now in your car because there's no plus-minus button, I think you should probably go to the configuration app, configure the vehicle when you do your drive profile, and set the default profile to something like comfort mode. No, set it to sports mode, standard mode, whatever you want to call it. That has slightly firmer shifting, so it should help if the gearbox decides to let go. Now, let me see if I can add some more CAN data to that table that might be useful. Oh, sport, sorry, I think it's called standard, just something beginning with an S. There's only one profile beginning with S. Actually, I could probably find out what that profile is. It is standard. Peter, no, we don't have any additional inputs. This is meant to be like a plug-and-play module rather than like a custom ECU. So it's a different purpose. Like, obviously, you've got other ECUs like off-gear and etc., which can do this kind of stuff. But for now, no, I don't have any I/O expands. But maybe it's a possibility in future. Maybe I'll make another board with more I/O expanders on it so you can add functionality to it in code. And just have a bit of fun with it. Oh, also, whilst I'm here, this is a pretty cool feature we've done. So, you can actually... Oh wait, let me change the firmware so it doesn't do it. Give me a sec to just quickly change the firmware. I need to go to Gearbox and just set... Oh god. Yeah, AB104 is right. You can pass data over CAD frames and then I can easily receive that. So if you want to write something to do CAN frame stuff, feel free. Like, that should be how I receive inputs. And maybe what we can do is we can ship modules which you can put into your car with like I/O expanders over CAN bus, if that makes sense. Okay, so this is what I want to show the people on stream. So EGS52 and 53 and 51 can do like a solenoid check, but it's extremely primitive in what it can do. I can tell you the exact resistance of every solenoid in the gearbox, transmission valve body, and then also adjust it for 25 degrees C and check if it's in with Mercedes specification on the fly. So I literally have to go to Diagnostic Routine Executor and do solenoid test. Oh wait, it's because the shift lever's not in reverse. There we go. And I also have to turn the engine off, so do that by that. Cool, so now if I say begin test. There we go. So you can see my TCC solenoid is a little tiny bit out of spec with a tiny bit too high resistance, but that's like, I'll adjust the range. But then I can see like the resistance of every single solenoid here, which is really, really cool. Actually, Lexi, it would be interesting for you to do the solenoid routine test in your 210 and see what it comes up with. Also, if people are yay, building the firmware, yay. Also, if people in chat are wondering how I deal with warranties, because I said like the release version of the boards will have warranties on them, it's quite simple. Look at this, query ECU serial number. There is a unique serial number written to the eFuse of every single TCU which I ship, and I know which serial number was released on which day with which ECU. So when basically, I mean, I haven't obviously trialed it yet, how warranty would work, but I suppose it'd be something like you have to write down the serial number of your TCU, and then I can look that up to see like if you're in warranty period, to see if like if it's a custom board that you've built, in which case I'm not supporting that. But if I built the board and it's broken, then I will support that. That's the plan. Man, it's getting tiring. I'm probably going to call quits to the stream in a bit, because I've been going for like 2 hours now. But yeah, I'm pretty happy with that. Lexi, if you can let me know later how this goes, and I'll add like how this goes for you into the video that I'm working on, which I'm hoping to release next week or the week after, depending on how much animation I can do in the next few days, because there's a lot of animation to do, and I'm also on holiday next week, so there's that. Also, check this. Look how much headroom we have on the CPU of this ESP32. Like, the TCU doing everything currently is only using, like, on average, like 9% of the entire chip, if you count for both cores. And only like 40% of its RAM, and 90 and 0.7% of SRAM, which not SRAM, PSRAM. So we could theoretically have like an insane amount of work that this TCU could do, which is kind of the main point. I want to eventually put a neural network on it for shift adaptation. But yeah, I think I will call ends to the stream for now. Because yeah, my eyes are currently hurting. So I hope everyone enjoyed this, and I will see you hopefully sometime soon. If not, it will be in a video that I plan to release soon. So goodbye everyone.